Hi everyone. Today we're going to study irrational numbers.
This is denoted by capital I. An irrational number is a number that cannot be written as the ratio of two integers. Its decimal form does not stop and does not repeat. Examples: the first is pi. The actual value of this pi is 3.141592654 and so on. We can see here that it does not stop and does not repeat, meaning there is no pattern of repetition on the decimal. So the pi is an example of irrational number. Another example, 3.605551275 and so on. This decimal does not stop. Also, there is no pattern of repetition. This is an example of irrational number. We have here square root of 2 and square root of 5. These are irrational numbers. So, we can conclude that square root whose radicand or the numbers inside this square root that is not a perfect square is considered to be an irrational number.
Example 1. Locate square root of 2 on the number line. Let us have this square OABC with sides 1. Then let us draw the diagonal OB. By Pythagorean theorem, we can compute for OB. That will be 1 square plus 1 square equals the square of the length OB. When we simplify this, OB is equal to square root of 2. On the number line, we put this O on the origin. Then we will use a compass. Center at O, radius OB. Then we will draw an arc intersecting the number line at the point P. Therefore, OB is equal to that square root of 2 and that will be equal to the line segment OP. Example 2. Locate square root of 3 on the number line. With reference to the figure of example 1, we will draw a right triangle on the number line such that we have the side OB as square root of 2, the side BD as 1. Then we will compute for the side OD. By Pythagorean theorem, we have the square root of 2, which is squared, plus 1 square is equal to the square of the length of the side OD. When we simplify this, the side OD is equal to the square root of 3. Then we will use a compass. Center at O, radius OD. We will draw an arc intersecting the number line at the point Q. So, OD, that is the square root of 3, now equals OQ on the number line. Note that you can locate square root of n on the number line for any positive integer n after the square root of the quantity n minus 1 has been located.